So in the last few videos, we've been working on solving quadratic equations using a method called completing the square. So I want you to take a look at this problem and tell me what's different about it as opposed to the other problems we've been working on. 3x squared minus 6x plus 30 equals 0. And I gave you a big hint here. What's A? A is 3. A is not 1. Uh-oh, this is our first one where A is not 1. So it says divide both sides by A first before completing the square. So we're going to divide everything by this 3. Divide by 3. Divide everything by 3. So let me rewrite. Because I'm going to go ahead and I'm going to divide by 3, divide by 3, divide by 3, divide by 3. Everything gets divided by 3. And then reduce. And so now we have x squared minus 2x plus 10 equals 0. So not so bad now. Now it doesn't look so bad. These are like the ones we've been doing. So we are going to subtract the constant, move the 10 over. X squared minus 2x plus, leave some room, equals negative 10 plus, leave some room. And then b is negative 2. Half of negative 2 is negative 1. Negative 1 squared is 1. So this is a 1. And whatever we add here, we add here. Factor x minus 1 squared. Over here, add these together. We get a negative 10 plus 1 is a negative 9. Square root property. Running out of room here. Plus or minus square root of negative 9. Uh-oh, complex numbers. Okay. Square root property with a plus or minus on the right. This is x minus 1 equals plus or minus. Okay. We have to take out an I, don't we? Square root of negative 1 times square root of 9. This is I. This is 3. 3i plus or minus 3i. And now we get x equals 1 plus 3i or x equals 1 minus 3i. What kind of roots did we get? We got 2 complex conjugates. Yep. Did you follow all that? Okay, we get to do it one more time. Look at number 7 because our A is not 1. So we're going to have to divide everything by 2. So let's rewrite. Just rewriting the problem here. And the first step is divide by A, which happens to be 2. So everything gets a 2. Just like that. Okay. So this is x squared. This is 15 halves. Ah, we have a fraction. Darn. And now let's go ahead and subtract the 25. So I'm going to leave some room here for my completing the square. And then this is going to be a negative 25 halves. And yes, we have ugly fractions, but we can do this. So b is negative 15 halves. Half of b is 1/2 times negative 15 over 2, which is negative 15 fourths. Okay, we got to square that. Negative 15 fourths squared is equals 225 over 16. So that's what's going to get added here and here. Yep, I know it's looking bad. Okay, but we can do this. Okay, let's factor this left-hand side. Remember, this is always going to be x, and then whatever you squared to get that 225 over 16, which was negative 15 fourths. So that's what goes in the parentheses, negative 15 over 4 squared here equals, now we got to add these two up here, negative 25 halves. So I need 16s down here, right? And 25 times 8 is negative 200. Plus 225 is 25 over 16. Okay. Now we're going to do our square root property. Square root plus or minus over here, square root of this guy. So we get x minus 15 fourths equals, gonna split up this radical, plus or minus square root of 25 over square root of 16. So we got perfect squares. So they were kind to us at least, right? This is what? Plus or minus 5 fourths. So my two answers, x minus 15 fourths equals positive 5 fourths. So I'm going to add 15 fourths to the 5 fourths. And that's going to give me, looks like 20 over 4, which is 5. Not too bad. So x equals 5 here. X equals 5. And then over here I get x minus 15 fourths equals negative 5 fourths. Add 15 fourths to the negative 5. So plus 15 fourths plus 15 fourths. Now I get x equals 10 fourths, which reduces to 5 halves. So my two answers, a 5 and a 5 halves. Rational. Nice rational roots, which I would personally use my calculator to check. So I recommend you do that. Okay.